Hello, I'm Mrs. J, and welcome to my math class. Today we're going to cover powers and exponential functions. And a power function is x to a number, p is an integer, and exponential functions are the x's in the exponent. So a power function has x to a number, and then the exponential has a number to x. So if we look at this example and we plug in some values to see how they're growing, you're just plugging in for x. So 0 cubed is 0. 1 cubed is 1. 2 cubed, 2 times 2 is 4 times 2 is 8. 3 cubed is 27. 4 cubed is 64. And 5 is 125. Now if we take 3 to a power, 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 81. 243. So this eventually is growing a lot quicker. At first, they're the same here, but then this one passes up. Right here's where they're the same value. Now if we look at a straight line, we know that that keeps a constant rate. So 3 times 0 is 0. 3 times 1 is 3. Times 2 is 6. Times 3 is 9. So it's definitely staying a lot slower. It's ahead in this when we plug in 1. Or no, it's not. It's tied with this one. 3 times 4 and 3 times 5. So what I do is I put the graphs in. X cubed, 3 to the x, and 3x to see how they grow. So this one's going to graph first, this will graph second, this will graph third, so you know which is which. So the power function's first. Whoops, I guess because I already graphed it. Well, you can see this one's the straight line. And then this one is ahead, but this one passes it up. So this one's the exponential. Now in your book you can see it a little better. This one's the power function, and this one is the exponential. The exponential starts out below, but then it passes them all up. Over here they show you a little closer view. Notice they're starting up here, 2,000, this would be 1,000. And it is definitely way above this one when you get higher. It's not even close. They zoomed so much that the straight line's not even in it. Number 2, examine the following 2 different versions of the graph. Notice this one's just zoomed in. For 3x cubed and 3 to the x. Notice that the version uses different scales on both axes. Make sure to check each version when answering the following questions. So the first one, well, let's look at which one is which. 3 to the x is this one. An exponential function approaches the axes. It will never equal 0. And the cubic looks like the snake. So this is the cubic. Well, oh, they do. When x is less than 0, how many times does f of x and g of x intersect? X less than 0 means this side. And notice if we only look at that side, they never cross. It's a little harder to tell on the zoom, but on this one, they never cross. So 0. How many times does f of x and g of x intersect? Well, looking here, that looks like 1. But when they zoom it here, it looks like 2. I think it's 1. Estimate the points of intersection. Well, 1, 2.5. But looking at this one, it looks like 1, 2, 3, 4, 5, 6. Maybe they cross twice. They cross at the 1, 2.5, but then up here they cross again at 5. These are 200s. So 200, 400, maybe 500. So about 6,500. As x approaches positive infinity, which one dominates? Well, as we get huge here, this one's definitely dominating because this one's going to go here and this one's growing even more. So it's the exponential. Which function, 10f of x or g of x, will dominate? The exponential will still dominate as x gets large. Oh, the exponential always takes over. Verse 6. Number 6. Let me move this down a little bit. Maybe that'll help. Here we go. Match the following data tables with the appropriate function. Well, to match, plug in just like we did and see which one it works with. So if we look at the first one, 2 over x, if we plug in 1, we get 2. So when you plug in 1, you get 2. So it works with this one and this one, but not this one. So it's one of these two. And then plug in a 2. 2 over 2 is 1. This is 4. So this one is A. And go to the next one. It's x squared. See it? Yeah. You plug in 1. 1 squared is 1, so it's not this one, it has to be this one. 2 squared is 4, 3 squared is 9, 4 squared is 16. So this is B. Still check and make sure your answer is right. 2 to the first is 2. 2 to the second is 4. 2 to the third, 2 times 2 times 2 is 8. Yep, this one is C. Let me just see which works. Number 8. We're doing the same thing, but we're looking at graphs. Notice these two are not starting at 0, but these two are. So that will help you split your graphs. If we plug in 0, this is 0. If we plug in 0 here, 2 to the 0 is 1. So this starts up at 1. So B is one of these two. And A is one of these two. So we know A is over here and B is over here. C, if we plug in 0, 4 times 0 cubed is 0. So C is over here. Move it up a little. So these are A and C. This is B, and let's double check. If we plug in 0 here, 3 to the 0 is 1. So this is 4. So B and D are on this side, and A and C are on this side. So we'll start with A and C. This is x squared, this is 4x cubed. This is going to grow faster because of the higher number in the exponent. So that would be this one, because it's growing quicker. This one's growing slower. But you can also plug in numbers. This was squared. 1 squared is 1. 2 squared goes up to 4. 3 squared is 9. 4 squared is 16. This is definitely A. If we check C, 0 is 0. If you plug in 1, you get 4. It's about there. If you plug in 2, it grows very quickly. So it makes sense. Now B and D. This one is starting at 2, 4, 6, 8, 10. Okay, so this is starting at 4. This one's starting at 2, 4, 6, 8, 10. So this is a 1. When we plug in 0 here, 2 to the 0 is 1. When we plug in 0 here, 3 to the 0 is 1. It starts at 4. So this has to be my D, and this has to be my B. So by plugging in a couple small values, you can find out which one is which. Okay, last one. Number 13 is finding a linear, a power, and an exponential function. It says, find the power, exponential, and linear equation that go through the 2 points 1.5 and 432. So for linear, that's just a straight line. Remember, to find the slope, it's y2 minus y1 over x2 minus x1. So if we plug those in, 32 minus 0.5 over 4 minus 1, we get 31.5 over 3, which is 10.5. So that's our slope. And then you use y minus y1 equals m times x minus x1. I'm going to use this point because it doesn't have decimals. So y minus 32 equals 10.5 x minus 4. Distributing the 10.5, we get 10.5x minus 42. And then add the 32 over. So linear would use this equation for these 2 points. For exponential, y equals abx. And our points were 1.5 and 432. So we need to find a and b. Plug the x and y's in to both equations. So I take the first one, it would have 0.5 equals ab to the first. Plugging the other one in, I have 32 equals ab to the fourth. So I could solve this one for a and plug it in here. That's just b to the first, so I could divide both sides by b, and I have 0.5 over b equals a. Then you take that and plug it in here. 32 equals 0.5 over b times b to the fourth. And this will cancel one of these and leave 32 equals 0.5 b cubed. Now you want to get b cubed by itself, divide by the decimal. 32 divided by 0.5 is 64. Now to get rid of the cube, you do the cubed root, or take it to the 1/3 power. 4 times 4 times 4. So b is 4. Now if we take and plug it in here, 0.5 divided by 4 is a, which is 0.125. So our equation for the exponential y equals 0.125 times 4 to the x. And that would be your exponential. Your power function is the form y equals ax, and they use a p for power function. So we need to find a and p. We're still using the same numbers, so we plug those in. Y was, so 0.5 equals a times 1 to the p. The other one is 32 equals a times x was 4 to the p. On this one, we know 1 to any power is going to be 1, so this drops off. So we know a equals 0.5. And then we can plug that in here. 32 equals 0.5 times 4 to the p. Divide by that 0.5. And we get 64 equals 4 to the p. We need to find p. 64 is 4 times 4 times 4, or 4 cubed. So that means 3 is p. So our function y equals 0.5x to the third. But that's everything in 7.4.